This is CPM Calculus Chapter 4, Number 9. So here we're asked to write a Riemann sum, right? Riemann sum using sigma notation that finds the area between our curve f and the x-axis between -8 and +8. For f of x is defined to be 2x to the power of 1/3 plus 1 using the number of rectangles given below. Then evaluate, okay? So that should be then. All right. So remember that the area we can know using Riemann sums is just equal to the base times the height for every rectangle that we're going to use to estimate it with. And for n rectangles, we're going to start with I is equal to whatever variable we want. I'm going to just say I is equal to 0 to the number of rectangles minus 1 times delta x, the base of every rectangle, times our function, right, at a plus delta x times I. So this is a generic term to always find the area using Riemann sums. Okay? That's the generic expression. Immediately, this tells us n is equal to 16. Okay? 16, so n is 16. -8 to 8 tells us a is -8, right? Starts at -8. B is +8. It stops at +8. Delta x then, right here, delta x is just equal to b minus a over n. B minus a is 8 minus -8 over n is 16. 8 minus -8 becomes positive, right? So that's 16 over 16, which is 1. Okay? So the area right here between our curve and the x-axis from -8 to +8 is approximately, using 16 rectangles, starts at I is 0, n we know is 16, so it goes to 15. Delta x we know is 1, right? We just calculated delta x, times our function f at starting at a, which is -8, plus delta x, which is again 1, times I. Okay? So that's the same thing as I equals 0 to 15. 1 times anything is just that something, so it's f. And this is just -8 plus I. Okay? We have the function f of x here, so we can go ahead and plug that in. That's the sum from I is equal to 0 to 15, right? F of that is equal to 2 times that, right? F of x, instead of x, we have -8 plus I. So we have 2 times -8 plus I to the power of 1/3 plus 1. Okay? So let's go ahead and evaluate this, right? Evaluate it in our calculator. Bring out your calculator, right? So you can go to catalog and get the sum, or you can just go ahead and push F3 and go down to option number 4, get the sum. The expression is 2 times -8 plus I. You can use x instead of I, but I'll just use I, so I'm going to use alpha, and I is right above 9. So -8 plus I to the power of 1/3. I'm put 1/3 in parentheses, so it's the whole power is 1/3, and then plus 1, comma, the variable we're using is I, right? So it's alpha I, comma, the start. So we're going from 0 to 15, so we're going from 0, comma, 15, right? I'm going to use the diamond here to approximate it, so diamond enter, and I get that's equal to 12. And the area, I'm going to say units squared, okay? So this is the expression, right? And that's it evaluated using 16 rectangles. All right, so part B, we want to use 64 rectangles. That just tells us n is equal to 64. We still are in the same region, so A is still -8, B is still +8. Delta x, though, is b minus a over n, which is 8 minus negative 8 over 64 now. So this becomes plus plus, so that's 16 over 64. We can leave it like that, but we know that that's just 1 over 4. So then the area between our curve, right, between negative 8 and positive 8, again, is approximately, we're going to start at I is equal to 0 and go to n minus 1, so that's 63. This time, delta x is not 1, so let's go ahead and account for that. It's 1/4 times, and then our function here, right, is just times f of a. So f of a we know is negative 8. Negative 8 plus delta x again is 1/4, right? Delta x is 1/4 times I. Okay? So that is what we want to plug in for our function. Let's go ahead and plug it in. The function's input is this now, so it's I equals 0 to 63, 1/4 on the outside. The function at this value, now we know, right? Here's our function of x. So instead of x, we have negative 8 plus 1/4 I. So we have 2 times negative 8 plus 1/4 I to the power of 1/3, right? That's just instead of x, and we still have plus 1. And make sure the 1/4 is outside of the parentheses here, because the whole thing here is f of this, right? That's the input. Okay? So we can plug this directly in our calculator. So again, F3, go to sum number 4, and our expression now is 1/4 times, and I'm going to open a parenthesis to write this in, 2 times, I'm going to open another parenthesis to write negative 8 plus 1/4 times I, so that's alpha, I is above 9. I want to be careful not to put the imaginary I above catalog, right, because that's a different I, that's just imaginary, but this is a variable I, to the power of exponent 1/3, right? Then I want to add 1, close that parenthesis that's being multiplied by 1/4, okay? So there is the expression, comma, the variable, again, is I, so alpha 9 gives me I, comma, my starting is 0, my stopping is now 63. Close the parentheses. I want to approximate it, so I'm going to put the green diamond, enter. I'm going to wait for that, and I know that that's approximately equal to 15 units squared. Okay, so let's put away the calculator. I see 64 rectangles gives me 15 units squared, excuse me, and this is the Riemann sum that I'm calculating. Okay, all right, so we see that if we increase the number of rectangles, we're going from 12 units to 15 units, and we know this is a better approximation for the area under the curve between negative 8 and positive 8. All right, so that ends for us CPM Calculus Chapter 4, I believe this is number 9, yes.